an important question on chemical kinetics. The question is, for the following reaction, the reaction is 2x plus y, rate constant K, and the product is P. The rate of the reaction is D concentration of P upon dt. That is, if represents a first order reaction is equal to K multiplied by the concentration of X. This is important for us. And then in terms of the product, it is given that dP by dt is equal to K into concentration of X. Thereafter, it is said that 2 moles of X are mixed with 1 mole of Y, 2 moles of X and 1 mole of Y, forming 1 liter of the solution. That means this represents the concentration. Now, at 50 seconds, 0.5 mole of Y is left in the reaction mixture. The correct statements or statement is about the reaction is or are, and ln is given equal to 0.693, ln2 log 2. Thereafter, the half-life period is given A, B, C, D. In first case, the rate constant is to be checked. Second case, half-life period we have to find out. And in the third case, that is in option C, the concentration of dx, concentration of x at 50 seconds we have to find out, and at 100 seconds we have to find out the concentration of y correctly. So in such a case, it is very important for us to check all the options one after the other and verify accordingly. हर ऑप्शन को अलग अलग हमको कैलकुलेट करना पड़ेगा, इन्फर करना पड़ेगा, समझना पड़ेगा. इसलिए हम फिर से ये रिएक्शन लिखेंगे and we write the reaction that 2x plus y, rate constant K, and the product is P. As given here, 2 moles of X and 1 mole of Y are taken, and in terms of concentration, it is in 1 liter. So here, 1 mole will represent 0.5 mole of Y. Definitely, this represents when 1 is converted to 0.5, that the time will represent the half-life period. Now we can write down the rate equation in terms of X, Y, and the product, and also the rate constant. If you write down the rate equation, it will be minus half d concentration X upon dt is equal to negative d concentration Y upon dt is equal to positive, of course, because it is a product, dP by dt, and this is equal to Kx as given. So here, this is just an inference about the reaction and the rate equation. Now, here it is very important, if we find out the half-life period or even K, we have to find out that 1 mole is converted to 0.5 and what is the time required here. And as given at 50 seconds, 0.5 mole of Y is left. That is, 1 is changed to 0.5 in the reaction mixture. Therefore, this represents the half-life period, and that is 50 seconds. So, half-life period, this way we can find out, and therefrom we can calculate option A, verify option A, that T half is 50 seconds, and we know that T half is equal to 0.693 upon K for first order reaction, and therefrom on simplification we find and we can calculate K, which comes out to be 1.386 into 10 to the power minus 2. The given rate constant in option A is 13.86 into 10 to the power minus 4, and therefore we can infer confidently that this is incorrect. Now let us move to the option other option, and that is option C. In option C, we have to find out the concentration when after 50 seconds. So here dx by dt, concentration of x minus dx by dt is equal to K into x, and K we have already calculated, and the concentration will be 1 mole per liter. So therefore, on simplification, you get it as 13.86 into 10 to the power minus 3 moles per liter per second. So that's the correct option. Option C is correct. Now let us check option D. To check option D, that means at 100 seconds, how much Y will be used up. We have to find out the concentration of Y here, dy. dy means it has to be negative. So minus dy by dt is equal to kx. And k we have calculated as 1.386 into 10 to the power minus 2. We have to apply here. And here, so far as y is concerned, it after 1 second, it will be left to half. And another next second, it will be left to half of the half. That is 1 upon 2 raised to power 2, or 1 upon 2 multiplied by 1 upon 2. And when you put up the values here, you get the correct answer as 0.3465 into 10 to the power minus 2, or we can simply write it in decimal notation as 3.465 into 10 to the power minus 3 moles per liter per second. And this corresponds to the option D, and therefore this is also correct. So finally, now we find that for this question, option A is incorrect. Option B, C, and D are definitely correct answers. Half-life period is 50 seconds. At 50 seconds, dx by dt is equal to whatever is given, minus 13.86 into 10 to the power minus 3 moles per liter per second. That's okay. And dy by dt at 100 seconds will be minus 3.46 into 10 to the power minus 3 moles per liter per second. So option B, C, and D are correct. So that's the right answer. Okay, I suppose you must have got it. And such questions are of moderate difficulty and more than one option correct. And they normally appear in different competitive examination, usually JEE examination. Okay, thank you. Please take up several other questions of this type, and that will bring confidence to you. Thank you very much. Please do share, like, and subscribe to this channel. Thank you very much again.